Much for that. Yeah, I just want to say welcome to Zilch. This is now the second meetup we're doing. We did an agentic AI one the other day. It's hard to imagine that we've been at this for 5 years flat out since we first launched, and we've never done really any of these kind of things. It's just, you get so stuck. I'm sure all of you are in the same position. You get so stuck into the day-to-day that you sometimes forget to stop and appreciate how far you've come. And one of the things that we've managed to do at Zilch is build an absolutely awesome team of engineers who are building some really innovative stuff that we're quite excited about. We want to share with the community, and this is really the starting point of that. So it's very nice to have the DevOps Society here. It's fantastic. It's a great initiative, and well done. And I think personally, my background is, I was a software engineer, right? I was writing code back in the day, and I first started hearing about DevOps in about 2009, kind of when it started out. We were managing a whole bunch of environments for the stock exchange, and we had to deploy to all these different servers, and we built all sorts of automation tools, and it was a pain in the neck. And the stuff you do nowadays in minutes was taking us days, weeks. And it really struck me how speed and feedback loops and iterations and cycle times drive so much in an organization. If you can just tighten that learning loop, make it smaller and smaller and smaller, faster and faster and faster and more assured, it's amazing the kind of multiplicative effect you get, this leveraging of everything. And this is one of the reasons why I've always been very passionate about DevOps. I'm thrilled to have passionate engineers such as Nick, who's going to talk to you about our ephemeral environment. So thank you very much.
Okay, so I'm Nick. I'm one of 4 DevOps engineers at Zilch, and I will be talking to you today about ephemeral environments. So this is going to be a quick talk. I'm going to run through a lot of complicated things fairly quickly. We don't have enough time to go in depth, but I did want to convey as much as I possibly could. So let's begin. So the agenda today, we're going to talk about what ephemeral environments are and why we want them. We're going to talk about our stack. We're going to talk about some of the constraints and challenges that we've come across while doing this, and our solution, Zephyr and Zoe. Title of the talk, big surprise. We're going to talk about the system design of that, the data ingestion and seeding of those, deletion, ArgoCD patterns that we've used, quite important, and the integrations that we put together. So what is an ephemeral environment? It's a lightweight disposable environment. So we want the environment to be thanks, Luke. We want that environment to be usable quickly. It needs to be disposable, so we don't really care if it sticks around or not. It's kind of a one-use thing. It needs to be usable as a stand-in for a fully fledged environment. So we don't expect 100% of things to be there. We expect 85, 90%. Tests need to run, all that good stuff. And we're going by the immutable infrastructure paradigm, cat or not pet. It's a standardized approach. We don't want to be fixing these things as we go along. If it doesn't work, we delete it, we build another one. So why do we even want them? So we've come a long way at Zilch. We do maybe 4, 5 deploys a month. We've got that down to 5 or 6 in a day sometimes. We are really running out of places for developers to test things in isolation. So ephemeral environments was the right choice there. We need better on-demand configurability. We want the developers to be able to configure the services as they want them and be able to, just do what they want with the services, scale them up, scale them down, scale them horizontally, just to have better testing available for them. And we need to scale our tests. We want to test in more places more early. The more tests we do before anything makes it into main, the better. This means pushing it as far left as possible, and this means if we want a developer to run tests on a branch, they need to have an environment for it. And we need more flexibility in how we use the environments. We do update things very quickly at Zilch. We tend to be on the bleeding edge of a lot of our integrations. So this means the newest Java version, preview builds of things. We just need to be able to test them without breaking the other environments. So what's our aim with this project? We need a usable, clean environment. So again, that means 85, 95% all there, all the tests run, they pass. It needs to be available in 15 minutes or less. We want these fast. We don't want developers to be waiting around waiting for an environment to build before they run their tests. We need composable test data. So this means we want the environment to be as clean as possible, but we also want to be able to select what data is seeded into it. And we need third-party integrations available or mocked. We're a fintech company. We have a lot of third parties that we use. So they need to either be there or they need to be mocked. And it needs to pull the configuration from the same source as regular environments. We're a small team. There's a huge amount of config for all the services. It all needs to be configured from the same place. You can override that config, but it all needs to be sourced in the same way as the regular environments. And it needs to be easily manageable by developers. DevOps is small. We have a 4-person team here. We don't want to hold developers' hands through setting these up and using them. If they want to change config, if they want to bring it up, if they want to delete it, they need to be able to do that themselves. So I'll run through our stack. So we're a cloud-native company. We are in AWS. That means SQS, SNS, S3, DynamoDB, all the usual suspects. We are running EKS Kubernetes. We're running 2 flavors, which is great fun, Fargate, and we are running EC2 with Carpenter. You can ask me why later. We are using ArgoCD. If you're not familiar, ArgoCD is a Kubernetes orchestration and deployment tool. It manages pretty much every environment that we have. We've set it up relatively recently. We've been running it for a year. And in general, it helps us maintain everything, and it gives us a lot of flexibility in the patterns that we use and a lot of flexibility in how we can deploy things. We're running Java microservices, relatively standard for an enterprise. People like to complain about Java. It's not that bad. You know, it works. There's common patterns available. It's a standard. We just use standards. We have TypeScript and Python lambdas. They're not all required for an environment to be there. But again, we want to test things as early as possible, as quickly as possible, and have as much available. This means we need to support that. We have an MS SQL database. There is an internal document. Yeah. Our lovely CTO, it was his choice when Zilch started. He's gone into depth explaining why we have to suffer. Yeah, he's posted an internal document which is essentially a long apology. So we also have AWS Aurora, it's Postgres. We are slowly migrating everything onto that, but it does mean that we need to have both of these available and ready for an environment to work. We're also running OpenSearch. Few services use it. Again, semi-critical to the environment. And we've got Redis. We're a fintech. Some things need to be very fast, hence the caching solution. So what constraints and challenges have we had with this? We have a lot of interdependent services. Some of our services are very old. They date back to when the company was started. This means they have interdependencies and reliability issues if you don't bring everything up at the same time in order. We have 4 years worth of schema changes which have never been applied from scratch. This means if we wanted a clean environment, we had to fix that. We have SQS queues and secrets that are relied on for the services to start. This is mostly a Spring Boot thing. That's the framework that we're using with our Java microservices. It expects everything to be available when the service starts. And yeah, third-party integration sandbox environments aren't freely available. We typically only have 1, maybe 2, if we're really lucky, UAT or pre-prod environments for our third parties. We need those. Our services rely on them. And again, we want that startup time to be fast, under 15 minutes. So our solution, Zephyr and Zoe. A Zephyr is our name for an ephemeral environment that we deploy with ArgoCD. So that is our entire self-contained Zilch environment. And Zoe is the name for the management engine that deploys, manages the lifecycle of the Zephyrs, Zephyr orchestration engine. There's a few components to Zoe. It's not just the operator. It's also an HTTP API and an ArgoCD generator plugin. So I'll run you through the system design. So first we have our static layer. This is going to be divided into a few different layers. We have a Terraform repo. With our Terraform, we provision into Terraform Cloud. And that provisions the base network, secrets, IAM roles, and the S3 bucket. The network, relatively self-explanatory, it's all in a big VPC. Secrets, so we have shared secrets for all the services that run in the ephemeral environment. They don't all need to have different secrets. They don't change that often. And then we have our ephemeral temporary layer. So we have in Git our application set and all our definitions for the resources we need to start, the service repos, base resources, and the data layer. So that's MSSQL, Redis, OpenSearch. We skip some of these for brevity. And then we have ArgoCD, which is doing all of the provisioning of that. And then that's provisioning a Zephyr namespace, and underneath that, it's provisioning all the services and all the init jobs. So that's doing the data layer, and it's doing the data seeding. At the same time, it's also integrating with some third-party APIs. So some init jobs start up, and they build a LaunchDarkly environment copied from one of the other environments that we've got, just to make sure that everything there is available. And again, we use LaunchDarkly quite extensively for testing. We need to make sure those flags work, hence LaunchDarkly available. And in EKS, we also have Crossplane, which I will explain shortly, deploying AWS manifests, and we have Carpenter managing all the nodes. And Crossplane there is deploying SNS and SQS. All good so far? Perfect. All right, let me take a sip, and I will explain this bit. So, in the management of this system, we have put together an API. The API can be done a few different ways. This example is showing the pull request tracker. So, when a PR is opened in GitHub, then makes a request to the Zoe HTTP API. That in turn goes to the K8s API, Kubernetes, and then that's feeding back through and then telling us, oh, hey, your environment is pending. Then that goes to the plugin generator API. So ArgoCD is always constantly polling that API to see if there's anything changed, any new environment requested, and then that then deploys a custom resource in Kubernetes, which then in turn is the definition of a single Zephyr. All good? Right, I'll take a couple of quick questions if anyone's got them at this point.
Quick.
Go ahead.
So is there an idea of like an environment queue? So if a developer or set developer.
Yes, you've touched on one of the things. The question was, is there an environment queue? Yes, there is. We found that if we try to build too many environments at once, we overwhelm the AWS API. So, and a few of the others, frankly. So there is a queue. So we typically only build one every 30 seconds. Or kick off the build of one every 30 seconds, so we're not overwhelming the APIs. We also have a warm environment, so that there's one already built that we can just add overrides to, so it's customized. That gets rebuilt very quickly, so when an environment is requested, it is then very quickly available. Any others while we're here? I'll take one more.
It's like one environment for one application or multiple applications?
One environment per either developer or PR. This is done on request, so we don't really have a limit on how many we make available. I guess if you want a hard limit, it's the number of IPs we've got available in the VPC, which it's a lot. Okay. Go on. The question was, how do we manage costs? Very cost-conscious architect there. So it's relatively cheap. Assuming that people don't spin up massive resources, you can just request a decently big AWS instance, EC2 instance on spot pricing, and that typically runs you 150 quid or so a month. If we're talking masses and masses of them, typically you won't have more than 10, maybe 15 on the go, and the environments expire. We don't let people keep them available. I'll talk about that in a minute. All right, moving on. So data ingestion and seeding. This is tricky. So we have our data managed in an S3 bucket, but it's all keyed and valued based on what it is. So there is a core data set, there's test data, and then there's stuff that's saved, snapshots, etc. We have a weekly job that ensures a clean snapshot with the most up-to-date schemas. So every week we bring up an ephemeral environment and we run every service with all the Liquidbase, that's a schema migration tool, and run it against the environment. This ensures that we have a clean database snapshot that we can then use for all the ephemeral environments. We do provision the data along with Zephyr kind of as soon as the database is available, just to seed all the data into it and make sure that when we run tests, it can be seeded in and then the data is available for the tests. We maintain multiple sets of test data for particular sets of tests, just so it's available and we know exactly what's in there. And this lets us tell if the test is breaking or if we've broken something else. We do have a mechanism to save a snapshot of database or table data based on an annotation. On deprovisioning, there is something called a pre-deletion hook in Argo. That runs a Kubernetes job that then goes away and takes that data and uploads it in test-free. So the deletion process, how that works. So it's based on an expiry annotation. All the expiry annotation is a timestamp. Typically, it's a week after the environment is requested. It can be extended or it can be shortened. So the Zoe operator then deletes via the Kubernetes API, or it sets finalizers in ArgoCD depending on what it is. So some custom jobs are run just because not everything deletes cleanly. We found that as hard as we might try to do everything through Kube, sometimes these things don't necessarily delete cleanly. So we have a custom job running, just making sure that everything is cleaned up when we do deprovision. So yeah, the default expiry is a week after creation. As if you requested earlier, it's just going to update to the latest time, and the next time the deletion API or deletion operator runs, it will bring down that that environment and make sure that it's all deleted, custom jobs run, etc., etc. Okay. So the main pattern that we've used with ArgoCD to do this is called the app of apps pattern. So it's a GitOps pattern. Essentially, we have a set of Git repos that hold values files, etc., just to configure everything. And we can manage dozens or hundreds of applications with a single parent app. This is part of what it looks like. It doesn't actually fit on the slide very cleanly. We have around 200, 250 apps that get built as part of a single ephemeral environment, single Zephyr. Not all of those are the service related. Some of those are jobs, some of those are AWS resources. We also use sync waves to solve our interdependency problem. So sync waves are an annotation available in ArgoCD. Essentially, all you have to do is say, I want this to be in sync wave 1, 2, or 3, as many as you like, really. And that lets you control the timings of what is built and when. So you can apply it at the individual manifest or chart level. And essentially, you can say, I want this to be built before this when this goes healthy. And health is a bit of an issue. We've had to implement some custom Lua scripts and stuff like that to make sure that health checks are correct. But once it's healthy, then you can start the next sync wave. So this helps us resolve our service startup interdependencies and make sure everything builds cleanly. So we've used Crossplane. We use Terraform. We've also started using Crossplane. We have it building our ephemeral AWS-related dependencies. We like Terraform, but the problem with Terraform is we'd have to manage it in a plan-apply static way, and we'd need to build an integration with Kubernetes to do that. Instead, we've gone with Crossplane, and Crossplane is essentially a control plane for Kubernetes. You can request resources through Kubernetes in AWS, and then that means that we can control everything in Kubernetes. So it's mainly SNS and SQS, which are simple notification service, simple queue service. It controls the other services as well, but we've got a lot of those topics and queues that the services need to start up. It lets us control the resource lifecycle a lot more tightly than we otherwise could. This means the whole thing is in Kubernetes, so that we don't have to go outside of Kubernetes to control the environment. We're using Crossplane 2.0. We were a pretty early adopter of that, just because it lets us namespace all the resources in the same way that we namespace our other Kubernetes resources. Before 2.0, we did have to have a namespace with, you had to have a namespace with the individual components in its own namespace. Now we can just have it namespaced with the Zephyr in the same location. Before this, we had to prefix everything to make sure we didn't have clashes. We don't have to do that now, which is excellent. So third-party integrations. Yeah, stuff like Launch Darkly, they've been integrated with Kubernetes jobs and cleanup scripts. A lot of bash, frankly. Still the best way to do a lot of things, but we can orchestrate it with Argo, which makes it easier. And other third parties, we've used YMock. We've used YMock for a long time at Zilch, and we've already got it pretty well built out for our dev environments. But now we can use it for our ephemeral environments as well and mock those third parties that we have an issue with. And each Zephyr has its own individual YMock, which means anything new that we need to test, any new config, it's already available to that Zephyr. You can configure that YMock instance without having too many issues. So let's run through the config. So basically, it's a lot of values files. We have a number of hierarchical values files, and any single value can be overridden by the Zoe operator or controller. And it's all sourced from Git repos. So this lets us control the sourcing of everything in the same way that we manage the sourcing of the other environments, even up to production. So you can select based on environment, you can override everything based on environment. This means if you want to test against production with a new service, you can bring up a mini production version-wise and override your single service. And you can say, okay, this integrates with prod as it stands at the moment. We can move this forward. We have a few different ways that we use the Zephyrs. The PR is the main way. We've standardized on a few options just to make sure that we don't have to maintain everything. Again, DevOps team small. DevOps team only wants to manage a few validated options so that we don't have to keep fixing things. Full configurability is available, but again, we only support those few config options and guarantee that it won't break. Otherwise, we'd have a lot more chaos to deal with. So, what does this mean for you? We're going to be open sourcing some of this. The Zoe system, so that's the controller, the API, and the ArgoCD generator plugin, and our cross-plane Helm charts, because frankly, there aren't any good public ones available. You guys might as well have them. Questions? How does it work in practice was the question. So in practice, it's been pretty good. In general, we can get them built within 10 minutes, which was better than the benchmark that we've got. Sometimes it's lower, sometimes it's higher, but it's hard to really figure out the performance issues that that timing stems from. And the developers have been fairly happy with them. In general, the PR is the main way that we're using at the moment. It's still early days with this. The project only recently really got going. We do want the developers to use the CLI and override stuff and do it that way, but that's not really gone gold yet. But the PR integration to the HTTP API has generally gone quite well, and testing has been a lot smoother. Question?
Which services pushed you into that sync wave?
Which services pushed us into that sync wave pattern? Our older services, frankly. So the newer services are pretty well behaved, but we have a few older services that came about more or less when Zilch started, and they have expectations on each other of when they might start. I'm not going to name names, but it's the older ones.
So ultimately in the backend it is creating EC2 instances.
Yes, in the back end, in EKS, it's creating EC2 instances, which then get pods deployed onto them. So that's using Carpenter and then the kind of general pattern. Essentially, most of the time it's one node to one namespace. Sometimes it differs. Any more questions?
Do you see a port for this for Azure?
It mostly depends on whether we start using Azure. We don't have a need for that at the moment.
How much Microsoft pay us?
That's true. The environment cost is also a good question. Whether we can get it a lot cheaper on Azure, if they offer. We expect some of the components to be, reasonably close to agnostic, so some of the components should be usable against any cloud environment that's hooked up to ArgoCD.
You mentioned that you use Carpenter.
Mm-hmm.
What is your experience with that compared to like the classical scaler?
Sure, I'll go through that quickly. So the question was, we've talked about using Carpenter here, and what's been the difference between a classic scaler. So Carpenter has been very, very good for us. Our older clusters are based on EC2 EKS Fargate, and the newer ones are EC2 with Carpenter. That's let us control the nodes a lot better. Carpenter is way, way faster than the Fargate is. We find Fargate will start a node in anywhere between 6 to 8 minutes. EKS with EC2 and Carpenter, that's around 30 to 40 seconds. So it's much, much faster. I don't know why so many people were adamant on EKS with Fargate. It hasn't been good. It's been a lot slower, and it's slower to scale. So against the old way of doing it with Fargate, a lot better.
So if I open PR,
Mm-hmm.
it's basing the service that I'm changing on code that the version of the code that is in the PR.
Yes.
How does that,
What's the mechanism by which that takes place? So the question was, if I open a PR and it tracks the code version in the PR, what's the mechanism by which that takes place? So because we are using ArgoCD, and it is a GitOps platform, we have what's called an application set in ArgoCD, and it has a generator. And now the generator pulls config from GitHub, and we've tagged each of the repos that we use, and essentially when we open that PR, you can then track that individual target reference for the PR, and you can go from there. So even as soon as the PR's been updated, it keeps updating the version, and it'll override with the newest build. It's a very elegant solution. We really, really like ArgoCD.
What's your typical kind of time to live, I suppose, if developers are saying, we need this, we want this, X, Y, Z?
Is that a general question, or with the Zephyrs?
Zephyrs, yeah.
So generally we try to be pretty, the question was about what's our general time to live if the developers request something with the Zephyrs. It really depends on how complex it is. For most things, it will be anywhere from a few days to a week. It also depends on how many other things the DevOps team has going on. This isn't the only thing we manage. We tend to be pretty responsive to developer requests. If they have something that we think is really useful, we'll implement it quickly. If it's something that we think might not serve too many use cases, we'll put it in the backlog and get to it when we get to it.
Sorry, quick one about the environment. You say that you can ask for like an extension on the...
Yeah.
So is there like a limit to that? 'Cause I'm assuming people don't just like extend.
Yeah. So the question was, we talked about extending the availability of the environments with the timestamp before they expire. And is there a limit to that? Yes, we typically won't allow a dev to keep an environment open for more than a month, just because we note that when we do that, there's degradations, there's other issues that pop up with the environment. Really, they should be just deleting it and requesting a new one at that point. We don't want these to stick around for too long. We don't want to nanny them, so it's something that we don't really support. Okay, anyone else? Oh.
Do you have any scalability concerns with Crossplane?
Do we have any scalability concerns with Crossplane? Our main one is we will not build 2 or more environments at once. We've spammed the AWS API, they don't like it. So we try to make sure that we queue things so we're not overloading the AWS APIs for the services. The main ones we overload are SNS and SQS. We've got a lot of queues. And then that delays service start time. So typically we queue environments so that we don't do that. In terms of scalability, we can have a lot of environments running at once. I think the most we've had is 20, and that was fine. We expect it to be more in use in future as we build out some of the other tooling that lets developers request them. But we expect we won't have too many issues until maybe 50 or 100 running at once.
We could create, set up other accounts.
Yeah, we could set up other AWS accounts. We've actually had to separate out our ArgoCD instance because, again, A lot of the issues there were with sharding of the app sets. If we have too many app sets, Argo doesn't necessarily intelligently place them on different nodes. So we've had to kind of trick it into thinking that different namespaces in different Kubernetes clusters, so it will shard correctly.
So it does auto healing as well.
So what's that?
Auto healing, like if any node gets down or
Yes, yes. All the nodes will auto heal.
Awesome. Any other questions?
Anyone else? All good?
Awesome.
Thank you very much.